And welcome to Virtual Investor Conferences. On behalf of OTC Markets, we are very pleased you have joined us for our Australian Rare Earths and Critical Minerals Conference. Our next presentation of the day is from American Rare Earths. Please note you may submit questions for the presenter in the box to the left of the slides. You can also view a company's availability for one-on-one meetings by clicking Book a Meeting in the top toolbar. At this point, I am very pleased to welcome Joe Evers, Interim Chief Executive Officer, and Tommy von Finkenstein, Director of Corporate Strategy of American Rare Earths, which trades on the OTCQX Best Market under the symbol AMRRY and on ASX under the symbol ARR. Welcome, Joe and Tommy.
Thank you very much, Lily, and thank you all for joining us. Tommy and I are very pleased to be here, and I'm excited to present this with Tommy. Tommy's got great insight into the market and a really good understanding of how we shape up in our place there. We're excited to talk to you specifically about our flagship project called Halleck Creek and the Cowboy State Mine therein. We'd like to hit on why we believe it will be the next producing U.S. rare earth element mine. And I'm going to, Tommy and I are going to walk you through and hit on a few points, but want to drive home the large resource, the scalability, the decades plus supply that we can present to the domestic market. We also want to highlight the strategic advantage that we have in the pathway to permitting with the state of Wyoming, which is unique to our project. And we want to drive home our belief in a technically and economically feasible project that will be further demonstrated with our forthcoming PFS. But I'll start off with some of those highlights. I already hit on the world-class resource. We've got the scale and grade to have a 100+ year opportunity here for the U.S. supply of these critical rare earths. We believe that Halleck Creek is scalable. The JORC resource is over 2 billion tons and very, very meaningful. And we had a recent press release to talk about bringing some of those up into the indicated category as well, if you want to check out our website. One thing to highlight here is that only a small portion of the mine has been, or the mining resource has been explored and highlighted, and that's what we'll talk about as it relates to the Cowboy State Mine. I also mentioned our strategic pathway to permitting. We're very differentiated in our space because the phase 1 of Halleck Creek, again, which is scalable, is located wholly on state of Wyoming owned land. So that is the surface resource is owned by the state of Wyoming, and in our case, the minerals are wholly owned by the state of Wyoming. And that's important and different than many of the projects that you might be familiar with here in the United States that often have a nexus to federal land, which requires NEPA analysis and federal permitting. Our project will be permitted wholly with the state of Wyoming Department of Environmental Quality with just as onerous of requirements, but a much more streamlined process that comes in around 2 to 3 years, which is much, much quicker than the decades plus that we often see in the federal permitting space. As I also mentioned, we've got a phase approach. Cowboy State Mine is the first phase located on that state of Wyoming owned land that I mentioned. And phase 2 can move off onto our broader claims, which include federal as well. And that's something that we did very purposely so that we can bring on the project in the most streamlined fashion and preserve that upside for future development. We think we've got a compelling economic case here. Tommy will dig into that further. And I want to highlight the government funding that we've received, especially from the state of Wyoming, because I think it validates that we're really in a unique jurisdiction that knows about mining, has a viable workforce, and knowledgeable regulators that we see as key to our success. In addition to the state support, we're working through the XIM process at a dollar amount that matches what we put forward in our scoping study. So those are positive things. And I just want to dive in a little bit deeper on the next slide so that I can give you some context where we are geographically. So As you can see on the map, that is the great state of Wyoming, which I'm fortunate to be speaking to you from today. I'm there in Cheyenne in the southeastern corner, which is the state capital, and we have some business here today. But I'll be very close to our project, which you see on the star, and we're kind of in the middle of these three cities here in Wyoming: Laramie, Wheatland, and Cheyenne. And we are in a very a jurisdiction that I said that's friendly, but we're in an appropriate place to develop, and we enjoy quality and meaningful relationships with our stakeholders in that area. As I already mentioned, big resource, world-class resource. We've got what it takes here. 100+ years, which is pretty incredible to try to wrap your mind around. But again, the volume of the resource really allows us to get to that place. The unique aspect of, you see here, the TRIO, and we're going to use a lot of acronyms, so feel free to ask us questions if you need us to explain here. But TRIO is the way we measure our total rare earth oxide. So basically, what kind of rare earths do you have? And as you see there, we're measuring it in the parts per million, which is fairly low. But through the upgrading process that we have been able to successfully work through with this ore, we can, just through physical separation and beneficiation, we can bring that up to the equivalent of 3 to 4%. So that becomes on par with other projects that you're familiar with, and we then enter into our leach that Tommy will talk about with a meaningful upgrade and a meaningful mineral concentrate that really feeds into the economics for us, in our opinion. It gets a little bit potentially confusing here because you're hearing me say Halleck Creek and Cowboy State Mine. But again, I just want to reiterate, the Cowboy State Mine is phase one of the broader Halleck Creek project. And we call it Cowboy State Mine because that is the moniker for the state of Wyoming, the Cowboy State. And we want to drive home to you that this project is located on state of Wyoming lands. And so just the Cowboy State Mine in the broader Halleck Creek province has a 20-year life of mine, and Tommy will hit on that further. So just to leave you here, we've got the strategic pathway, we've got the resource, and we can do this with proven technology that leads to a technically and economically feasible project. So I'll kick it over to Tommy.
Yeah, thanks, Joe. So as Joe mentioned, we have a large resource, both heavy and light rare earths. So where does that put us in terms of how we fit into the United States' rare earth supply chain solution? And in our view, there's been an immense amount of magnet capacity that's been that's planned to be developed, let's call it, over the next decade. And for example, like the Mountain Pass MP Materials and the Department of War announced a 10,000 ton per annum magnetics facility. USA Rare also has a few thousand tons that's planned to come online. And I believe recently Vulcan, another magnet producer, announced about another 10,000 tons. So you have all this magnet capacity coming online, but you only have one producing rare earth mine in the United States. So if we don't, so what that leads us to is if you don't diversify the upstream portion, the mining portion of the supply chain, you're ultimately in the same position you are today, which is reliant on China, as you would need to buy the oxides that feed those announced domestic magnetics facilities. And given the kind of large scale of our resource, just with the base case Cowboy State mines, that phase one development, we could supply up to 57% of the light rare earth needs and approximately 30% of the heavy rare earth needs of a 10,000 ton per annum facility. So that gives you just the scale of this project. And note that Cowboy State mine is really only 20%, 25% of the overall Halleck Creek resource. And given its very near surface, almost a zero strip ratio, like if you came to site and grabbed a rock off the ground, it's likely ore. The large scale of it really points to that we have both the extensive life of mine and the potential expansion capacity to really fulfill a lot of those downstream magnetics facilities. And then a big question for a lot of rare earths here is, and this is not unique to our project, is how do you process them? Because processing rare earths, as many of you might be familiar with, is not like processing gold or copper, where it's a very well-known and almost cookie-cutter solution. Everyone's ore is a little bit different, and getting those rare earths out of the rock can be difficult. So over the last year, we've done extensive work through the whole flow sheet, all the way from comminution to the downstream kind of impurity removal and solvent extraction, that is pointing to a very technically and economically viable flow sheet. As Joe alluded to earlier, our in situ grade is about 0.3 to 0.4% TRIO or total rare earths, which is, at least on an in situ basis, a lot lower than the currently producing mines today. So how do we overcome that? Just through the process of milling the ore down to like essentially a sand, mixing with water, no chemicals or reagents at this point, running it through gravity spirals, and then taking that concentrate and running it through a dry magnetic process. We're able to upgrade that ore about 10 times prior to going into leach, in addition to leaving a lot of the non-rare earth materials behind. And that's important in the leaching step, because going into leach, you want to keep as much rare earths while minimizing the amount of mass going into leach, because leaching costs are directly correlated to mass. So when we're in that leaching step, we not only have the higher grade of the 10-time upgrade, we also have a lot of mass. You're leaving about 90 to 95% of the non-rare earth material behind. And our ore, Halleck Creek's ore, is a little bit unique. It's an allanite, which is not a conventional rare earth source. However, we're proving that it can be. And part of the reason historically allanite-based rare earths are quite difficult to leach and require an extensive amount of reagent. There's kind of other rare allanite-based projects that need about, let's call it 800 to 1,000 kilos of sulfuric acid per ton of concentrate to leach. So the purpose of leaching is you take that concentrate and you put everything in that concentrate into a solution. So you want to use as little amount of reagent as possible. And our ore points to using about half of that 800 to 1,000 kilos of sulfuric per ton of ore. And the reason that we're able to be approximately half of the reagent use is nature, in a way, pre-processed our ore for us through this natural phenomenon called metactimization, which is basically the allanite crystals, which host the rare earths. A lot of the radioactive elements over the 1 billion to 1.5 billion years of age of our deposit kind of decayed out and kind of broke down the crystal structure for us, allowing us to have this very favorable leaching process. So after you've performed leaching, all the rare earths, and at this point, all the non-rare earths material from the concentrate are in a solution. And the goal of the next step is impurity removal, which is how do you get all the non-rare earths out of that solution while keeping all the rare earths in it? And the way you do that is through changing the pH of that solution. And every time you change the pH, a different impurity or non-rare earth will kind of solidify and drop out of the solution. And over the summer, we did extensive testing, which shows magnesium oxide is a good kind of neutralization agent to change those pHs, and while keeping a lot of the rare earths in the solution. And historically, the impurity removal step has been a very difficult one for allanite-based rare earths like ours, because when you add those neutralization agents, historically would kind of gunk up the whole system and create like this slime. But with the testing we did over this summer, we saw none of that kind of slime material materialize, or a very minimal amount. So all of these different things that we've done over the last year kind of brings us to this next slide here. And this looks like a lot complex, but really what it is showing is that we're developing a flow sheet that, one, uses only conventional technology that's been used in other operations around the world, whether it's rare earth or not. And we're getting to a point where we're just kind of optimizing, and those are those orange boxes, a few small portions of the flow sheet to kind of maximize our rare earth recoveries. But the work that we've done over the last year really gives me confidence that we're getting to a spot where we are going to show that Hallett Creek ore can be technically and economically produced using a flow sheet that only employs kind of conventional technology. And then I'll kick it back to Joe here. He's going to talk a little bit more about the upcoming catalysts we have.
So I don't want to spend too much time on the slides here. We're getting a few questions up in the chat specifically around next steps and milestones. So I'll kind of hit on those here. The top part of this slide just showcases some of the things that we have done to get to where we are. The bottom portion of the slide are what we have to do next. But I think when it comes to the milestones, there's really three key milestones to think of here. And that is bringing forward the PFS, filing the application for the permit to mine, and beginning work on our pilot facility, which I think will unlock a lot of potential from a product standpoint and strategic partners and offtake opportunities in that regard. So with those kind of milestones coming up, we're looking at 26 for those activities. But I thought, given some of the questions in the chat, it might be worthwhile to give a quick explanation of state permitting specifically in the state of Wyoming and how that stacks up with federal permitting. So it sounds like there's a fair amount of knowledge from folks regarding the baseline studies that we've already undertaken. So that is the vegetation, the wildlife, the air, the water, all of the natural resources that touch this land that we're seeking to develop, and defining what the baseline is so that you can then move forward with a permit application to say, this is how we will mitigate X, Y, and Z. This is how the mine fits into the existing kind of ecosystem and other things present on the land. That has all been undertaken. Those have statutory requirements for how long you must sample those things like air, water, et cetera. So we're underway on all of that. And once you file the permit application in the state of Wyoming, there's kind of a statutory pathway that the state legislature has defined so that you know that when you file it, you have this much time for them to respond. Once it's deemed that you've got an appropriate application, you have this much time to move forward, you have stakeholder engagement, et cetera. That, to me, is part of that strategic advantage in being in a top-tier jurisdiction like we are in Wyoming. That stuff is a little, in my opinion, a little more opaque on the federal side and often takes decade plus to maneuver. So the final thing I will say on the state permitting is that there's a recent precedent in the state of Wyoming. If you'd like to check another avenue, it's called CK Gold, and their project is right outside the window here. I can see out to where it's at here outside of Cheyenne, Wyoming. But they were able to navigate the Department of Environmental Quality permit to mine process in around 2 years. So that's a strong precedent that we have going forward in the state of Wyoming. Tommy, do you want to take a look? There's kind of several questions coming in, and we have plenty of time here remaining with folks.
Yeah, so I think there's one question on the optimization work we're doing, in particular to reduce the amount of fines. So if we go back to this slide, that's kind of at that front end process. And we started that. So in August of this year, we undertook a test mining program at the Cowboy State Mine to extract a few thousand tons of material, which will kind of has dual purposes. One will provide the feedstock for a future demonstration plant, but the other was to perform and get the necessary volumes to do comminution work. So we're testing a few different types of comminution. One is a high pressure grinding roller mill. One's a vertical roller mill, as well as a kind of a more novel technology that's Wyoming based called DISA. And we shipped all that material out, let's call it early September. All of the material has been arrived at different vendors across the world, including Germany, Salt Lake City, someone to Australia. And that testing work is ongoing. A lot of the tests are being completed as we speak, and those results should be kind of flowing in towards the end of the year and early next year. And ultimately, why we were looking to optimize that front end is the more we can reduce the amount of fines generated in our process, which is under 53 microns in terms of size, so very, very small, the better the beneficiation process works and can point to a better upgrade and higher recoveries going into leach. So that's kind of, originally we were targeting, let's say, the PFS by year end. And as we did a lot of the extensive engineering work to meet that target, we found that there was a few kind of areas. One was comminution, where there was really some really low-hanging fruit that if we just spent an extra couple months on, we would ultimately get a much better product, a more robust product, and more viable product for the pre-feasibility in regards to the flow sheet. So I hope that answered one of the questions. There's been a lot of questions about ongoing discussions with offtake parties. That's something that is currently ongoing. We don't have anything to announce on this call, but however, what I can say is that for a lot of these offtake discussions, you need to send kind of a substantial amount of material to the counterparties in order to get a binding agreement. You might be able to get something like an MOU or something that's non-binding. However, to get a binding offtake agreement with a lot of parties, you need to show at scale that you can produce these separated rare earth products. And that's just given that it's not like copper or gold, like I said before, where processing is quite straightforward and people understand it. Because processing rare earths really hasn't been done at extent for decades in the Western world, you need to show these offtake parties that you can do it and provide them with those volumes for them to test to make sure that your product meets the qualifications for their needs. And this is something that will be enabled with a demonstration plant. That's the work on that is kind of ongoing in terms of engineering and ordering equipment. So that kind of ticks off the box on the offtake question. And then
I can hit on the similarly. There's several questions about government engagement, specifically at the federal levels in the U.S. and Australia, and obviously that is top of mind for the company right now, and we're doing everything that we can to make sure that we avail ourselves to potential opportunities, but do so in a way that we're highlighting the project from a strategic standpoint and making sure that we're speaking to the correct people. We think that we have a unique opportunity being represented well as a corporation, both in Australia and the United States. There's been several questions alluding to the recent meetings between Prime Minister Albanese and President Trump. I think that we are unique in my understanding as we are one of the only, if not the only, ASX listed rare earth companies with a domestic project. And we think the domestic project at Howlett Creek is very unique. From a strategic standpoint on that front, I think one of the differentiators that we have, there's another question, and Tommy, you can chime in here as well, that talks about how does the project stack up in a way that mitigates the risks from Chinese interference, to kind of put it generically. But I think if we think about the domestic rare earth ecosystem in upstream, downstream, or upstream, midstream, and downstream contexts, we're very focused on the upstream. There's only one other producing rare earth element mine in the United States. And as Tommy alluded to in his remarks, the downstream side is very well represented. There's more magnet capacity coming online. There's been a lot of attention there of late. We think that our focus on the upstream gives a strategic advantage for the project to ensure that we have a little bit of diversity of domestic supply on that front end, and that we can alleviate potential pinch points in a supply chain that's overly reliant on one domestic source or or small amount of domestic sources. Further, I think this group seems to have a very good understanding of the MP and Department of War contract and arrangement and ongoing efforts. I think you see some really key elements of that arrangement that kind of will serve to bifurcate potentially the market between China, ex-China, and showing things like the guaranteed floor price, potential offtakes. Granted, those are not extended to the broader market, but I think they give a signal of where things are going. Our base case from a production standpoint is very strategically designed to not flood the market, to not come in and present challenges in that way. But on the flip side, as demand changes and increases, this project, in my opinion, is very uniquely situated to scale up to meet those needs in a quick and efficient way domestically. Is there anything you'd like to add, Tommy?
No, I think you hit on that question quite well. And there's another question coming here, kind of when we expect to be in commercial production and cash flow positive. The way we view this is that, and Joe kind of just hit on this, and I talked a little bit about it earlier, is that currently, like, there's a lot of downstream capacity that's announced. It's not actually operational yet. So what does that really mean? Like, even if we were able to start producing tomorrow, there would actually be very few places outside of China that we could sell into. So the way we view it is that, given our state permitting advantage, and that we're kind of making a lot of material progress on the technical de-risking side as well, if all goes well, we could be in production, let's call it start of the next decade, which really lines up quite well with a lot of this announced magnet capacity being ramped up. So if you can think about it, it's a bit of a chicken and the egg problem where it's like, okay, well, currently, as it stands today, there's really no material magnet capacity in the United States, nor is there the upstream. However, both are kind of being developed in parallel. And my guess would be towards the end of the decade, a lot of these things start to materialize and become operational at scale. There's another question here about, like, what's preventing us from expanding the Cowboy State Mine beyond the
I could take that one, Tommy.
Sure.
I'll dig into that one again. I think the folks on the call are going to get tired of me highlighting the strategic permitting advantage that we see here in the state of Wyoming. The question is around, you've got a very large resource, over 2.6 billion tons. Phase one at the Cowboy State Mine is a small portion. Is there anything preventing you from expanding beyond the current base case scenario? And the short answer is no, there isn't. And the way that we've designed this with phase one and phase two, in our opinion, gives us the most streamlined pathway to a producing, revenue generating project on the state of Wyoming lands that has that very advantageous pathway to permitting that we highlighted. And then when you're in that position, having revenue, having a runway allows you to navigate a potential federal permitting scheme in a much stronger position. And instead of being locked into that federal permitting regime where you have no revenue and no runway, you are able to enter that from a position of strength, in our opinion. And I think the other thing that's worth highlighting here, and Tommy, feel free to jump in, but the base case can be scaled up to meet the demand that Tommy was talking about just a moment earlier. And I think that's important to recognize, because if you come out with a project that floods the market, even from a domestic standpoint, we're entering into the same problematic scenarios that we've seen where the Chinese can flood the market and kind of take away that capacity, if you will. So I think, Tommy, what are we at? About roughly an estimate would be around 20% of the domestic overall demand. And you can scale that up from a production standpoint because we have such a long runway. But I mean, I think that's I want to drive home that the base case as it stands is a very meaningful amount of domestic demand. It takes care of a lot of domestic demand. So we are out of time here, and I just will kind of wrap up by thanking everyone for their time, reiterating that we believe we have a generational asset here. the 100+ year production really takes it to the next level. I'm sure you're tired of me talking about Wyoming, top tier jurisdiction, pathway to permitting. We've got a technically and economically feasible project here that we're seeking to advance and de-risk, and we think that results in the next producing rare earth element mine here in the U.S. And we hope you join us, and we appreciate your time. Thank you all very much.
Thank you.